Hello everyone, my name is Katrina and today I'm going to tell you about the project I've been doing with Just Eat for the last couple of weeks. So I believe we all know what Just Eat is. Just Eat is the food delivery platform where you can go online, order your favorite dishes and enjoy them at home within 30 minutes. However, here's the question every user faces: how to find exactly what you want at the Just Eat platform. Individual restaurants have their own menus and their own unique formats. However, if those menus to be uploaded on the Just Eat platform, they have to be standardized to a user-friendly Just Eat format. So the question is then, how do we make this standard user-friendly menus? Here's an example we're all very familiar with, a can of Coke. Different restaurants can call the can of Coke a bit differently. However, on the platform, we want to have similar items to have similar names. And here is a somewhat simplistic example. If we move to a more complex example, like here, so we have a dish, chicken tikka masala, which has slightly different description in different restaurants. And again, Just Eat wants to standardize these descriptions on their platform. So therefore, the question is, how do we produce the standardized menus? You don't want to do this by hand. Currently, Just Eat holds around 30 million individual items. So you want to have automatic, fast pipeline to standardize these menus. And it is important to standardize the menus in order to improve the user experience, as well as for the Just Eat to understand their market sizing. So during my project, I specifically focused at standardizing the drinks. So I was given a set of menus with different, a set of menus where similar items were given standardized names that Just Eat wants to see at their platform. And then I trained a classifier built on the basis of the support vector machine to predict the target labels, standardized labels, for the products from the Coca-Cola and Pepsi brands. And my algorithm was pretty successful. I was able to achieve 99.8% precision on the evaluation set. Despite this high precision, my algorithm was still making mistakes. So we want to know how to automatically identify wrong predictions. And in order to answer this question, I incorporated probability estimates in my classifications. So what do I mean by that? Here you can see an example where my classifier makes a correct prediction and a wrong prediction. So when it makes a correct prediction, the probability associated with this prediction is high. However, when prediction is wrong, the probability associated with this is low. So when you look at the small percentage of my wrong predictions, you can see that most of the probabilities are low, somewhat below 0.5%. So at this point, we have a classifier that can identify products from Coke and Pepsi brands with high precision, as well as we have a tool that can identify where it made the wrong prediction. However, how does the algorithm behave when new products are introduced? The products that are outside of the Coke and Pepsi brand. So in order to answer this question, I looked at the evaluation set where 20% of the items were outside of the Coke and Pepsi brands. And you can see that precision did drop. However, I can still use the probability threshold to identify the wrong predictions. Again, you can see that the probabilities associated with the wrong predictions are below 0.5. So to summarize, I was able, during my internship, to build an algorithm that predicts the standard labels for the drinks with high precision, as well as there is an inbuilt tool to identify where it made a wrong prediction. And this means that Just Eat can now automatically label their items that saves time, as well as they can understand the market sizing of their products better. Thank you very much.